And anything outside the thermodynamic system is called as surroundings. Good. Putting those two into proper sense, coagulating the definition of thermodynamics, we say, where do you place these components? Within specific regions called boundary between the system and its surroundings, exchange of matter as well as energy. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. A new session, a new topic. What is that we are discussing here? What does my bowl of fruits contain today? A very new chapter, something called as thermodynamics. I can say, students, this is a continuation of whatever we studied in the previous chapter. Meaning to say, I require the topics of my previous sessions to understand thermodynamics better. All that you have learnt in the previous sessions will be employed here so that analysis of thermodynamics becomes very, very simple. Now, what is that I have got in store for you all today? The very first thing, we will understand what actually is thermodynamics. What is the physical significance of thermodynamics, and how is it different from my previous chapter? Once I understand what is thermodynamics, we will understand the nature of thermodynamic system. What is a thermodynamic system? The different types of thermodynamic system. And finally, we understand under what conditions thermal equilibrium is achieved. So, these are the bulletin points, the aims of our session on thermodynamics today. So, without further lag, we will start understanding the chapter. Now, to clearly understand or to clearly explain what is thermodynamics, I will split that word into two. The first thing, what I call as thermal, plus the second thing, what I call as dynamics. So the word thermodynamics I split as thermal plus dynamics to understand what is thermodynamics. In a simple manner, I have break opened, resolved the word thermodynamics into two. First, what is called as thermal, the other one, what is called as dynamics. Now, to understand further, we know thermal means heat. So, the word thermal refers to heat and dynamics refers to motion. Being dynamic, we have already studied in our first chapter, motion in a straight line. So the word thermal refers to something called heat, and the word dynamics refers to motion. Therefore, putting those two into proper sense, coagulating the definition of thermodynamics, we say the branch of science, the branch of science which deals with the transfer of heat. It is the branch of science which deals with the transfer of heat from one place to another. A simple statement to define thermodynamics. What is that? It is a branch of science, a branch of physics which deals with the transfer of heat from one place to another. So that is what we studied in the previous chapter. You taught us modes of heat transfer. You taught us conduction, convection, and radiation. Then what difference is thermodynamics making? Additionally, in thermodynamics, we study how mechanical energy is converted to work and vice versa, which means how work can be converted into mechanical energy, and this is the physical significance of studying thermodynamics. So, my dear students, if you simply analyze, thermodynamics is not simply understanding how heat flows from one place to another, which we have already done in the previous chapter, where we have studied the three modes. But what is significant here? We understand as heat flows from one place to another, how mechanical energy is converted into work, and how work can be converted into energy. ಮಕ್ಕಳೇ, ಈ ಒಂದು ಕಾನ್ಸೆಪ್ಟನ್ನ ನಿಮ್ಮ ಲೋವರ್ ಕ್ಲಾಸಸ್ ಅಲ್ಲಿ ಒಂದ್ ಕಡೆ ಓದಿದ್ದೀರಾ, ಸ್ವಲ್ಪ ನೆನಪಿಸ್ಕೊಳ್ತೀರಾ? The phenomenon of converting mechanical energy into work. Good. Heat engines. Here we describe a very specific heat engine called Carnot's heat engine, and that is all the basic aim of understanding thermodynamics. So we say the branch of science where we understand the transfer of heat, the flow of heat from one place to another, and in addition, as heat flows, thermal dynamics, how mechanical energy is converted into work, or how work is converted into mechanical energy. Now, once I have understood what is a thermodynamics, the next important thing for me is to understand thermodynamic system. What actually is a thermodynamic system? By definition, it is a collection of large number of atoms and molecules. System ಅಂತ ಕರಿತೀವಿ. System ಅಂತ ಕರೆದಾಗ, whenever you call something as a system, there should be a number of components in it. So, large number of atoms and molecules. So the first statement to define a thermodynamic system is collection of large number of atoms and molecules. Now this is important. Without definite boundaries, these atoms and molecules should be placed within a definite space. We have to identify a definite boundary. So, large number of atoms and molecules which are collected or which are placed within definite regions, definite place, and that region is called a boundary. We have a specific corners in which these components are placed, and they should have specified values of temperature, pressure, and volume. So these atoms or molecules are collected at defined temperature, pressure, and volume. These atoms or molecules have to be maintained at a definite temperature. You cannot allow the temperature to keep on changing. They should experience specific pressure. Constant pressure should be acting on them, and specific values of volume. Once these three parameters are satisfied, then you say that is a thermodynamic system. So, any thermodynamic system is defined under three conditions. Which are those three conditions, students? First, large number of components. What are those components? Atoms or molecules. Where do you place these components? Within specific regions called boundary, and they should have specified temperature, pressure and volume. Such an arrangement is called thermodynamic system. And anything which is external to this system, which is out of this system, is what we call as surroundings. Any region, any space which is outside the thermodynamic system is called as surroundings. So, one thermodynamic system alli ಏನೇನು ಇರಬೇಕು? Large number of atoms or molecules. ಎಲ್ಲಿ ಪ್ಲೇಸ್ ಆಗಿರಬೇಕು? ಈ atoms ಅಥವಾ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅನ್ನ ಸ್ಪೆಸಿಫಿಕ್ ಬೌಂಡ್ರಿ ಒಳಗಿಟ್ಟಿರಬೇಕು. ಮಾತ್ರ ಅದ್ರ ಮೇಲೆ ಸ್ಪೆಸಿಫೈಡ್ ಟೆಂಪರೇಚರ್, ಪ್ರೆಷರ್, ವಾಲ್ಯೂಮ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಬೇಕು. ಈ ರೀತಿಯಾದಂಥ ಫೀಚರ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಿದ್ರೆ then you call it as a thermodynamic system. And anything outside the thermodynamic system is called as surroundings. Good. Now we have understood the nature of a thermodynamic system. And hence, now we make an attempt to understand the types of thermodynamic systems. We say there are three types of thermodynamic systems. One is called open system. The other one is called closed system. The third one is called isolated system. ಮೂರು ರೀತಿಯಾದಂಥ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ನ ಐಡೆಂಟಿಫೈ ಮಾಡ್ತೀವಿ. ಯಾವ್ದ್ಯಾವ್ದದು? ಓಪನ್ ಸಿಸ್ಟಮ್, ಕ್ಲೋಸ್ಡ್ ಸಿಸ್ಟಮ್, ಐಸೋಲೇಟೆಡ್ ಸಿಸ್ಟಮ್. What is an open system? Open thermodynamic system. It is a system where both matter and energy is exchanged between the system and its surroundings. So, if you consider me to be an open system, this is my surroundings. What is happening? There is continuous transfer of matter between the system and its surroundings. Exchange of matter as well as energy. ಒಂದು ಸಿಸ್ಟಮ್ ಮತ್ತೆ ಅದರ ಸರೌಂಡಿಂಗ್ಸ್ ಜೊತೆಗೆ ಮ್ಯಾಟರ್ ಮತ್ತೆ ಎನರ್ಜಿ ಎರಡೂ ಟ್ರಾನ್ಸ್ಫರ್ ಆದ್ರೆ, ಎರಡೂ ಎಕ್ಸ್ಚೇಂಜ್ ಆದ್ರೆ ಅದನ್ನೇನ್ ಕರಿತೀವಿ? ಓಪನ್ ಸಿಸ್ಟಮ್. ದ ಸಿಸ್ಟಮ್ ಇಸ್ ಕ್ವೈಟ್ ಓಪನ್. How? There is continuous exchange of matter as well as energy between the system and its surroundings. Closed system, very important. Here, only energy is exchanged but not matter with the surroundings. Andre, there is no transfer of any other physical component except energy to the surroundings. ಒಂದು ಕ್ಲೋಸ್ಡ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಎನರ್ಜಿನ ಮಾತ್ರ ಹಂಚ್ಕೊಳ್ಳಕ್ ಸಾಧ್ಯ, ಬೇರೆ ಯಾವ ಫಿಸಿಕಲ್ ಕಾಂಪೊನೆಂಟ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗಲ್ಲ. ಪ್ರೆಷರ್ ಆಗಿರಬಹುದು, ಟೆಂಪರೇಚರ್ ಆಗಿರಬಹುದು, ಎಂಟ್ರೋಪಿ ಆಗಿರಬಹುದು, ಇದು ಯಾವುದೂ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗಲ್ಲ. ಬರೀ ಎನರ್ಜಿ ಮಾತ್ರ ಫ್ಲೋ ಆಗುತ್ತೆ. ಅದನ್ನ ಕ್ಲೋಸ್ಡ್ ಸಿಸ್ಟಮ್ ಅಂತ ಕರಿತೀವಿ. ಸಿ, isolated system. Isolated, completely separated from the surroundings ಅಂತ ಅರ್ಥ. Here, neither energy nor matter is exchanged between the system and its surroundings. Isolate ಆಗೋಗಿದೆ. ಸರೌಂಡಿಂಗ್ಸ್ ಜೊತೆ ಯಾವುದೇ ರೀತಿಯಾದಂತ ಇಂಟರಾಕ್ಷನ್ ಇಲ್ಲ. ಐಸೋಲೇಷನ್. ಪ್ರಿಸನರ್ಸ್ ಆರ್ ಐಸೋಲೇಟೆಡ್ ಫ್ರಮ್ ದಿ ಸೊಸೈಟಿ. ಐಸೋಲೇಟ್ ಮಾಡೋದಂದ್ರೆ ಕಂಪ್ಲೀಟ್ಲಿ ಸೆಪರೇಟ್ ಮಾಡ್ಬಿಡೋದು ಅಂತ ಅರ್ಥ. ಸೊ ಓಪನ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ? ಮ್ಯಾಟರ್ ಮತ್ತೆ ಎನರ್ಜಿ ಎರಡೂ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗುತ್ತೆ. What happens in a closed system? Only matter does not flow. Energy is exchanged between the system and the surroundings. Isolated system, neither energy nor matter is exchanged. Now, again a very important term, thermodynamic variables, or this is also called thermodynamic parameters. Variables, parameters, or quantities. By definition, the behavior or nature of any thermodynamic system is completely specified by using quantities like temperature, pressure, volume, entropy, enthalpy, etc. ಇಲ್ಲಿ ನಾನು ಏನು ಹೇಳ್ತಿದ್ದೀನಿ ಅಂದ್ರೆ, I want to analyze the nature of a thermodynamic system. I want to understand the behavior of a thermodynamic system. So what should I look into? I should try to understand the quantities called temperature, pressure, volume, entropy, etc. For example, if it is an isothermal system, condition ಏನು? If it is an isothermal system, Boyle's law ಓದಿದಿರಲ್ವಾ? So temperature should remain constant. So to understand the behavior of an isothermal system, I know temperature has to remain constant, whereas pressure and volume keeps on changing. So I am referring to quantities called temperature, pressure and volume to understand isothermal systems. So these quantities are called thermodynamic variables. So my dear students, thermodynamic variables or parameters are those quantities which will completely explain what is the nature of a thermodynamic system. What is the behavior of a thermodynamic system? If the system is disordered, chaotic, ಒಂದು thermodynamic system ಅಲ್ಲಿ randomness ಜಾಸ್ತಿ ಆದರೆ, then I will refer to something called as entropy of the system. So any quantity, any variable which will explain the nature of a thermodynamic system is what we call thermodynamic variables. And classically, to conclude, we will understand thermodynamic equilibrium, where equilibrium means some type of balance. Basically understand, when we talk about equilibrium, a balance has to be achieved. Balance andre gottalva, two factors should equate. Why do I stand firm on the platform? My weight becomes equal to gravitational force. Therefore, I am in balance. I am in equilibrium. So here, we are talking about thermodynamic equilibrium, which is achieved only when three conditions are satisfied. First one, ಮೆಕ್ಯಾನಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಥರ್ಮೋಡೈನಮಿಕ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಸಿಗಬೇಕಾದ್ರೆ ಥರ್ಮೋಡೈನಮಿಕ್ ಸಿಸ್ಟಮ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲಿ ಇರಬೇಕಾದ್ರೆ ಈ ಮೂರು ಫೀಚರ್ಸ್ ಇರಬೇಕು. ಮೆಕ್ಯಾನಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ, there should be no unbalanced force between the system and its surroundings. Suppose energy or matter is exchanged between the system and the surroundings, then there should be no unbalanced forces coming into picture. The force should be balanced. Unbalanced ಆಗೋದ್ರೆ ಏನಾಗುತ್ತೆ? Definite boundary ಇರುತ್ತೆ. The boundary is broken down. System is not defined. So there should not be any unbalanced force. When matter and energy is exchanged, the forces coming into picture, the physical forces should balance. Only then mechanical equilibrium is attained. Thermal equilibrium, temperature of every part of the system should be the same as the temperature of its surroundings. Thermal, heat, temperature of each part of the system should be the same as the temperature of its surroundings. Chemical equilibrium, the chemical composition of the system should not change due to the chemical change between system and its surroundings. Suppose in a container I have water. If there are chemical reactions happening between the system and the surroundings, still water should remain water. That chemical composition should not change. Then we say chemical equilibrium is attained. And when these three equilibriums are attained, we say the system is in thermodynamic equilibrium. So my dear students, in my today's session, I've given you an outlook as to what thermodynamics is, what is a system, different types of systems, and when thermodynamic system is in equilibrium. By next session, we will focus on the first law of thermodynamics. Until then, have a great time. Thank you.